Hi, I'm here with a new chapter called Lines and Angles. You have quite a good idea about different types of lines and angles. And in this chapter, we will explore more about them. First things first, let's take this video and revise some important concepts so that our foundation is rock solid. Let's begin with a line. What is a line? It's straight, it has no width, and these arrows here indicate that it extends infinitely in both directions. Or we can say that a line is a straight one-dimensional figure having no thickness and extending infinitely in both directions. So, if we name this line AB, we denote it like this. And what if we replace one of the arrows, say A, with a fixed point? What do we get? Correct, a ray. So, a ray extends endlessly in only one direction. We represent the ray AB like this. And if we replace this arrow too with a fixed point, we get a line segment. It's a segment or a part of a line. It doesn't extend endlessly in any direction. Or in other words, it has a fixed length because its ends are fixed points. And we denote a line segment AB like this. So, lines have no endpoints, rays have one endpoint, and line segments have two endpoints. Though each of them have different characteristics, in this chapter, we will denote them using the same symbol, in this case AB. Now sometimes we also use small letters like L, M, N, etc. to denote lines. Now, if three or more points lie on the same line, they are called collinear points. Collinear actually comes from two root words, co and linear. Co means together, just like incorporate, operating together, and linear indicates a straight line. So, collinear means together on a straight line. Got it? Great. Like this is a straight line and A, B, C and D are 4 points on it. These are called collinear points. Now there are some other points which do not lie on the line. These points are called non-collinear points. You must also remember that while considering points to be collinear, they are taken in groups of 3 or more, never individually. For instance, P, Q and S are collinear, but P, Q, S and A are non-collinear because all of them together do not lie on the same line. So keep this in mind, collinear, together on a straight line. Now, lines can be parallel or they can be intersecting. Like here, these two lines are parallel. They are always the same distance apart and hence would never meet or intersect, which is why they are also called non-intersecting lines. But if I give one of them a nudge, they will intersect at some point or other. So now they are intersecting lines. You can see that the distance in between decreases as they eventually meet. Now, let's take these intersecting lines and truncate each of them at their meeting point. So what do we get? Two rays starting from the same point and forming an angle. This point is called the vertex and these two rays are called the arms of the angle. We have studied about different types of angles in our previous classes, right? An angle that measures between 0 degrees and 90 degrees is called an acute angle. Easy way to remember, acute starts with A and A looks like an acute angle. Now, an angle that measures exactly 90 degrees is a right angle. Its arms are perpendicular to each other. An angle that lies between 90 degrees and 180 degrees is called an obtuse angle. And an angle that measures exactly 180 degrees is a straight angle because its arms together form a straight line. But what if one of the arms rotates completely and overlaps the previous arm? we get 360 degrees. This one is called a complete angle, perhaps because one rotation is complete. So that's all about different types of angles. Well, wait a minute. Are we forgetting something? What about an angle that is greater than 180 degrees and less than 360 degrees? It's called a reflex angle. So, between 0 degrees and 90 degrees, we have acute angles. At 90 degrees, we have right angles. Between 90 degrees and 180 degrees, we have obtuse angles. At 180 degrees, we have straight angles. Between 180 degrees and 360 degrees, we have reflex angles. And at 360 degrees, we have a complete angle. Now that we have discussed a little about angles, let's look at the different relations between a pair of angles. Say this one. This angle measures 60 degrees, whereas this one measures 30 degrees. What would happen if we combine them together? They will add up to measure 90 degrees, right? So two such angles whose sum together form 90 degrees are called complementary angles. Easy way to remember. Complementary starts with C and so does corners. And we know that corners generally measure 90 degrees. Now, an important thing to remember is that complementary angles are always in a pair. 3 or more angles whose sum is 90 degrees are not complementary angles. So, in a pair of complementary angles, one angle is said to be the complement of the other. Also, these angles need not always be together, like this. They can be anywhere. The only requirement is that their sum should be 90 degrees. Now, there is a special name for any two angles whose sum is 180 degrees. They are called supplementary angles. Easy way to remember, supplementary starts with S and these angles together form a straight line which also starts with S. Here again, supplementary angles are always in a pair. 3 or more angles whose sum is 180 degrees are not supplementary angles. So, in a pair of supplementary angles, one angle is said to be the supplement of the other. Even in supplementary angles, two angles need not be together. They can be anywhere. As long as their sum is 180 degrees, they are called supplementary angles. But if a pair of supplementary angles is together, it forms a linear pair. So what are the characteristics of a linear pair? Their sum is 180 degrees. They have a common arm and the non-common arms together form a straight line, which is probably why they are called a linear pair. So remember, two angles together forming a straight line are a linear pair. Moving on, we have another pair of angles called adjacent angles. Adjacent as a word just means next to. These angles are literally next to each other. They must have a common vertex, a common arm, and most importantly, they must not overlap. So here, angles A and B are adjacent angles. Here is the common vertex, the common arm, and clearly these angles don't overlap. There is one last pair we are discussing today, and that is a pair of vertically opposite angles. When two lines intersect at a point like this, they make 4 angles. Out of the 4, these two are vertically opposite to each other and these two are vertically opposite to each other. So, each of these pairs are called vertically opposite angles. So this was all for today. Now let's do a quick recap. Lines have no end point, rays have one end point, and line segments have 2 endpoints. 3 or more points which lie on the same line are collinear points. Otherwise, they are non-collinear points. Lines can be parallel or intersecting. Two different rays starting from the same point form an angle. Angles have different names depending upon their measures. Between 0 degrees and 90 degrees, acute angle. At 90 degrees, right angle. Between 90 degrees and 180 degrees, obtuse angle. At 180 degrees, straight angle. Between 180 degrees and 360 degrees, reflex angle. And at 360 degrees, complete angle. Any two angles that add up to 90 degrees are called complementary angles. Remember, C for complementary and C for corner. Any two angles that add up to 180 degrees are called supplementary angles. Remember, S for supplementary and S for straight line. A pair of supplementary angles that have a common arm and the non-common arms together form a straight line is called linear pair. Adjacent angles are angles that are next to each other. They must have a common vertex, a common arm, and must not overlap. Vertically opposite angles are the angles opposite to each other when two lines intersect.